We'll get started in just about a minute. All right. Hello, everyone. Happy Friday to you. Today is set aside for any questions you may have about exam 2. It's going to be a similar format to the first exam, which means up to 25 multiple choice questions. Up to 2 of those may be fill in the blank. So it could be 0, 1, or 2. I will tell you this question will have a bonus to it, so stay tuned. You can try that. I always recommend trying all the questions, even if you have no clue, because you never know, you might get it right. I actually had a student once completing an exam, and that student had one question left, and it was going to take a while to compute it, but it was multiple choice, took a guess, guessed right. So you never know. So always, I think it's in your interest too. If you're not sure, at least take a stab at it. Also, please bear in mind that the note sheet is non-optional this time. It is required. It has to be unique. It has to be your own. You can't copy from someone else. You are allowed front and back, and worth up to 5 points on the exam. So definitely worthwhile to do that. You also have your concept checklist and formula sheet posted in D2L. And I did post this morning a exam to review with the 5 questions like we had last time. At least one of those questions will appear on the exam as is. I might change the order of the response choices, but other than that, it will be on the exam, same wording, everything. Remember, other questions may appear on the exam, but with different wording and might yield a different answer. So it could be the same setup, but a difference in the scenario, right? So please stay tuned for that. Please read carefully. You'll notice if you watch the video, I almost gave you a wrong answer on the last one because I misread effect size as I misread it as increase instead of decrease. So watch out for those things. I'm not trying to be tricky with my wording, but you just got to pay attention because it is a specific topic like that. Statistics just kind of works that way. So I also am finishing off your 2 quiz reviews, but we can review them here if that's something you want to do. We can go through quizzes, we can go through topics, we can go through anything off the concept checklist. It's really up to you. All you need to do is ask. So please chat in, or you can even speak up. I think there's a small enough group that we probably won't have overlap, but if you're able to chat in, that would be great. And just let me know if you have any questions or if you'd like me to review something, and I'll be happy to do it. And again, that can be quizzes, that can be, if you want me to go through what I did this morning in terms of the actual exam review, I can go through that in person, we can do anything. So time is yours. Yeah, how about reviewing, sorry, someone just tagged in with a chat. So let me do that first, and then I'll get to you, Caitlin, or you can chat yours in as well. Sorry about that. Could you review cutoff values and how to find them? Yes. So cutoff values are what's in the table. So cutoff values are what's in the table. So I'll answer this other question real quick because it's an easy question. How much time will we have to take the exam? Same as last time. You will have 50 minutes, but the exam will start. I'll start it at 9 a.m. when the class is, and I'll end it at 11:59 p.m. at night. So anywhere in between 9 and 11:59 at night, you can take your exam. Just leave yourself 50 minutes to take it. Okay. All right. Once you start, you can't leave and come back, those sort of rules. But yeah. Okay. So now let's talk about cutoff values and how to find them. So let me quick pull up a Z table for you. Just give me one moment to do that. Okay, so I have a Z table right here. I'm going to share it with you so you can see. This is the harder of the two tables in my personal opinion. So I'd like to go through that one first. However, there is something you can do if you don't like the table. Okay, so for the purposes of exam 2, I'm pretty much going, the thing you probably need to know is what your cutoff value is, right? Okay, so if alpha is 0.05 and it's one-tailed, your cutoff value, the way you find it, is you go to percent and tail, and you're going to, and we're going to scroll all the way down until we find 5 in the percent and tail column. So I'm scrolling to the 3rd page already. And finally, I keep going down this percent and tail column. I see a number close to 5. In fact, I see 2 numbers close to 5. But in this case, we're going to use 5.05. That's by convention. So that's something maybe goes on your note sheet, just to remember that. And the corresponding Z score is 1.64. So if you hate the Z table, here's what you can do. There's only 4 things I'm ever going to ask you. I'm either going to ask you for a 5%, an alpha of 0.05 or an alpha of 0.01. It's either going to be two-tailed or one-tailed. So there's really only 4 numbers you have to know. Okay, so you can learn to love the Z table, or you can kind of make part of your note sheet the 4 numbers. So, okay, if percent and tail is 5, that's one-tailed, alpha is 0.05. Again, we're down here and our number is 1.64. If percent in, if the alpha is 0.05 and it's two-tailed, okay? You have 2 tails this time. How much are you going to have in each tail? You got to divide by 2, right? You're going to have 2.5% in each tail. What's the corresponding number? Positive 1.96 or negative 1.96. Positive 1.96 or negative 1.96. So that's option 2. Now let's say that we're on to option 3 and we have an alpha of 0.01, one-tail test. I'm scrolling down to 1% in my tail and I got to keep going into the 4th page. 1% in my tail. Closest number is 0.99. The corresponding Z is 2.33. Now that may be, just like with the 1.64, that may be a positive or a negative depending on which side we're looking at. Are we looking for an increase or are we looking for a decrease? Okay. And then finally, if it's two-tailed, alpha equals 0.01, we're down to 0.5%. Scroll just a little bit more here. And we can see 2 numbers equally close again by convention. This time we use 0.49. And the corresponding Z is positive 2.58 and negative 2.58. So when it's two-tailed, it's both the positive and the negative because you can be higher than 1.96 or lower than negative 1.96. You can be higher than 2.58 or lower than negative 2.58. However, when it's one-tailed, you got to know which side the tail is on. Okay, so those are basically the four numbers you need to know from here to be able to look for cutoff scales in the Z table. Okay, so now the T table is, in my opinion, a little bit easier. Let me just find that for you real super quick, and then I'll show that one to you. And I see there's more chats coming in, so I appreciate that. That's great. I'm in the wrong place. Sorry. I need to get rid of this. Sorry, just give me 1 second. Back to here. Okay. Here's a lovely T table that I'm about to pull up for you. Okay, this one, like I said, is much nicer in that. Okay, hopefully you see that now. If you're, I'm just going to check the chats just to make sure you're not saying you're not seeing it. Okay, sure. Okay, let me get to those in a minute. But okay, you're seeing the T table. If you're not seeing the T table, just like someone wave your hand at me so I can see. Okay, I think you're seeing the T table. It looks like it's in my share. Okay. So here, there's three things you have to know for finding the cutoff score. Is it one-tailed or two-tailed? Ask yourself that question first. Is it one-tailed or two-tailed? One-tailed, go to the left. Two-tailed, go to the right. Next, what's your alpha? Okay. Alpha is, and it's not going to be 0.10. So you can eliminate those columns right off the bat. It's going to be 0.05 or 0.01. So yes, find your 0.05 or 0.01. Next, what's your DF? Remember, DF does depend on the t-test. If it's a t-test for a single sample or a t-test for dependent samples, it's n-1. If it's a t-test for independent samples, it's sample size 1 plus sample size 2 minus 2. So we'll just pretend it's one-tailed, alpha is 0.05, and I figure out that in my samples I have a group of 10 and a group of 12. So 10 and 12 is 22, minus 2 is 20. So I've got to go down to 20. One-tailed, 0.05, 20. My cutoff value is 1.725. That's the number to beat. Okay, and because this is one-tailed, I have to know, am I trying to beat positive 1.725 or negative 1.725? I have to know that, and the way I know that is which way the direction of the problem is stated. If it was two-tailed, we'll keep the same example. Alpha is 0.05, and it's a t-test for independent samples with two samples, 10 and 12. Again, our DF is 10 plus 12 minus 2, 20. This time my number to beat is 2.093. This time I can be either higher than 2.093 or lower than negative 2.093. Notice here, when they show the one-tailed, you got to be all in one tail. Here you can be in either tail. Okay, I hope that helps a little bit. Let me go back to the chats. Looks like some more has come in, so I want to answer those questions. I'll post this lecture on YouTube, sure. That will be really, that sounds like it'll be helpful. Yes, I will post it on YouTube. Okay, so next question. Is there a way to go through a problem where we're doing some kind of a t-test because that's confusing. I'm not sure which step to begin at certain procedures where the information has already given us the variance and other things. Oh, okay, you wanted the 4 numbers again too. So it was 1.64 for the z-test. Someone asked for the 4 numbers again. 1.64, 1.96, 2.33, 2.58. Okay. All right. I hope that helps. So yes, we can go through a t-test setup. Let me find one for you. And then someone else wants to go through how to distinguish between the tests. So let's do all of that. So let me think of where I can find a good t-test example for you and where to start. I have an idea. Give me 1 second. Okay. Okay, so let me share this with you. Give me a second. You share. Okay, so here is an example of a something that you might encounter. And this might help us answer both questions of how you distinguish between the tests, as well as how you know which step to start with. Okay, so you wish to test a new treatment for major depressive disorder. You obtain a sample of 6 participants. These 6 participants complete a well-known inventory for major depressive disorder before and after the new treatment. Higher scores indicate higher levels of depression. The scores are below. You wish to know if there is differences between scores collected before and after the treatment. Okay, assume alpha is 0.05. So first thing, which test should you use? Before treatment, after treatment, I see 2 scores per participant. Immediately, I know which test it is. That's all I have to know. There's 2 scores for each participant. We have only talked about one test that has 2 scores for each participant, and that is the t-test for dependent samples. Okay. Now, just to be even more clear, how do we eliminate some of the others? Well, t-test for independent samples would be I had 2 different groups. So instead of 1, 2, 3, 4, 5, 6 people here, total, I would have had 12 people, right? 6 who took the one treatment and 6 who took the other treatment, let's say. 2 different independent groups means independent samples t-test. Okay. And then there's only 1 score per person, 2 different groups, 2 different samples. And we'll go through an example of that. Let's do that. But the one sample t-test would have been if I was comparing a sample to a population. So then there would only be 1 number per person, 1 score per person, plus a population mean that you were given. Okay. All right. Now, how do you know which step to start with? Okay. So you were just sharing, if you were given the variance. So if you're not given raw data, you never start with step 1. Step 1 is only if you're given raw data and you need to calculate, you're given raw data and you're not given a variance. If you are given any kind of variance, you get to skip step 1. So in this example, I get to move on to this step. Sorry, this one I wasn't given a variance, but I know in your homeworks I gave you always a variance. I gave that to you so you didn't have to do that SUSAD by hand. Okay. I think that's you're kind of past that, at least in terms of homework at this point. So then you get to move on to step 2. If I give you so let's stick with dependent. If I give you a variance, you can move on to, maybe I should pull up those. Well, you get to move on to standard error. You get to move on to standard error. If I give you a standard error, you get to move on to the actual calculation of the t-test. That's true for the dependent samples t-test. That's true for the single sample t-test. And the z-test, you're always given the variance no matter what, so you never have to calculate a variance. Now the t-test for a independent sample is a little bit different, because even if I give you both variances separately, you got to calculate the pooled variance before the standard error before the t-test. If I give you the S squared pooled, the pooled variance, what's the next step? Standard error. And if I give you a standard error, what's the next step? Always the t-test. Okay, so the basic order is always going to be variance. In the case only of t-test or independent sample, pooled variance, then standard error, then t-test. Okay, so that's your basic order, and you've just got to look for which one you are given. So another possible thing to consider for your note sheet might be, we can go through that actually in more detail, but might actually be those little step guides that I gave you. But let's take a look at this so we can at least see. This comes with, I can share this with you too in case you want to see like another practice example. Maybe that would be helpful for you. Maybe I'll post this if you think that's helpful. Okay, so in this one, it's the z-test, and how did we know that? Well, let's see. You are exploring the relationship between caffeine intake and response time in a driving simulator. You have 36 participants drink a 6-ounce cup of coffee and have them complete a driving simulation task. The group obtains a X bar sample mean of 392 milliseconds. You know that mu, population mean, is 400 milliseconds, and sigma equals 40. So this sigma, again, is what? Population standard deviation. What's that? A form of population variance, z-test. You see some form of sigma in there, you've got a z-test, okay? Okay. Now, once again, this one gave you the variance and the two means, so all you have to calculate is the standard error and then the z-test. Okay, let's look at another one. Yes. So what about this one? The monthly, and I like this one. So yeah, I like this one a lot because I think it's kind of more similar to your homework in a certain way. The monthly rent for a 2-bedroom apartment in the borough was recorded for a sample of 10 apartments. And here is the 10 apartments, their prices. Do these data support the claim that the mean monthly rent for a 2-bedroom apartment is higher than $775? Alpha 0.05. So this says single sample t-test, which means I'm comparing a sample to a population. Where is the mu? Think about it for a second. Where is the mu? Okay, if you guessed it was 775, you're right. That's it. That's what we're assuming the population mean is. That's what we're looking for a difference from. That's your mu. These are your x's from which we can get an x bar. If variance had been given, all I'd have to do is take my x bar. I still have to get my mean here, but I take my x bar minus my mu over sigma over the square root of n. Or I might want to do the standard mean first, right? I might, if I was given the variance, then that's actually sigma squared. So I might go ahead and calculate my standard error first rather than trying to do it all in one step, and take square root of sigma squared over square root of n, get my standard error. Then take that, plop it in, and I can take x bar minus mu over that standard error. If I'd been given standard deviation, so again, that just brings up another point. If it's variance you're given, it's square root of the variance over square root of n. If it's the standard deviation you're given, it's standard deviation over the square root of n. Because what is standard deviation? The square root of variance. Okay. And let's look at this last one, then I'm going to come back to more questions. You wish to know if there's a difference in the sizes of butterfly wings in the two species of butterflies. You obtain two sample measurements of the size of butterfly wings for the two species. On average, there's a difference in size of butterfly wings in species A as compared to species B. Assume that alpha is 0.01. What test should we use? Two species, two independent samples. Species A, species B. Independent samples t-test. Okay, all right. Let me go to some more chats. Let's see what else we got here. Okay, so I think I took care of those two. Is it possible to go over how to calculate CIs? Yes. I will post these practice problems with the solutions on D2L. It sounds like that is interesting to people, so I will post them. So yeah, let's talk about how to calculate CIs, confidence intervals, right? So I'm trying to think of where I can find an example of that for you. So give me a second. I might go to the lecture. Okay. Let me find the correct lecture for you. Okay. Okay, so I know this is from the lecture, but I'm going to go through this example anyway, because I think it does walk you through the right way. So let me share this with you. Okay, so here is an example of a confidence interval setup. Okay, we have to be given a standard deviation or variance, and we have to be given an n. We have to be either given or given the way to calculate an x bar. So you might be just given all the sample numbers, right? The scores, and then how do you get an x bar? You add them up and divide by the number of scores, right? That's how we get our mean typically. Okay, so the one other thing we have to know is what the alpha is. Now it's either going to be a 95% confidence interval, which translates to 5% in the tail, which is divided into, or a 99% confidence interval. So this is another one that I think might be just worth, either memorizing or making a note of. There is a way to understand that if it's 5%, then it's 2.5% in each tail. This goes back to that number from the Z table, 1.96. Had it been a 99% confidence interval, that would mean 0.5% in each tail, which means 2.58. Okay. All right. So really, those are the two numbers it's ever going to be if it's 95% versus 99%. Okay. In this case, it was a 95% confidence interval. So we immediately want to set up two equations that look like this, with, like I said, either the 1.96 here or the 2.58 here. If I'm given a variance as opposed to a standard deviation, then I take the square root of sigma squared over the square root of n, or I take the, or if it's just a standard deviation, it's sigma over the square root of n. Okay, so now the only other, I think the main tricky thing here is the order of operations. So let's talk that through. You take the square roots first, whether I have one or two, do that first, get that done. Then do your division. Then do your multiplication. Then you'll notice both numbers, right? Up to this point, the numbers are the same, 5.88 and 5.88. So that's good because we only have to do that once really, right? This is the same on both sides. Square root's the same, division's the same, multiplication's the same. Finally, take our mean, our x bar, subtract, take our mean x bar, and we add. And that's how we get the confidence interval. I think I'm going to answer the next question in just a second, but the other reason to get a confidence interval wrong is if you don't know the rounding rule, right? So I want to just quick review the rounding rule, and then I promise I'll get to the next question in just a second. So rounding rule. Can I use the rounding rule right here? Nope, I wasn't given the original data. Okay, now I'll tell you. Oh, by the way, the original data has one decimal, which means one number after the decimal place. How many decimals will your confidence interval have? How many numbers after the decimal point? 2, because you added 1. That's all you have to do is just add 1. Okay, now I'll tell you actually in the original data, I lied. Actually in the original data, it's all integers, no decimal places, no numbers after the decimal point. How many will be in your final answer? 1. 0 plus 1 is 1. So it's just a matter of how many decimals are in your original data. Okay, and if I want you to use the rounding rule, I will tell you. Okay. Okay, next question is, in regards to the single sample t-test, how do you know the n for the equation? So n is sample size. So if I gave you raw data, just count up how many numbers there are. If I didn't give you raw data, then I would tell you there are this many people in the sample. Or I'd say 25 people did so-and-so and were compared to the typical mean, which is so-and-so. Then the 25 people would be your n. Okay. Next. Okay. So we have another question about the Z or T tabled cutoff scores, which I did go through. So let me go through the second part. When would it be multiple values as compared to 1? Let me readdress that part of it. And then if you want to, maybe I did go through the rest of the Z or T tabled cutoff scores. So maybe listen to this. I'm going to post it afterwards. Maybe listen to this or hang back after, and I'll be happy to talk that through with you if we have some extra time. But I don't want to go through the same thing quite again in the same session. So okay, when would be multiple values as compared to 1 in the Z and T cutoff tables? If it is two-tailed, multiple values. It's either plus or minus. So, and that's two-tailed for Z, that's two-tailed for T, that's two-tailed, okay? So when you have a two-tailed test, it can be, for example, Z test, alpha of 0.05, two tails. The answer is 1.96 or negative 1.96. When it's one-tailed, it's either going to be positive or negative, not both. So if I said that group A will be higher than group B, and you're comparing group A to group B, then most likely your cutoff score will be positive. But if I said group A will be less than group B, then most likely you will have a negative cutoff score. Okay, all right, so you just got to watch the direction of what you're looking at. Okay. I'm caught up on the chat. So if you guys, if you guys have anything else, oh, we have another chat. Good. Let's see. Yeah. Okay. The relationship between power and effect size when rejecting the null hypothesis. So that's an interesting question. First of all, let me start with power and effect size. Okay. As effect size goes up, power goes up. As effect size goes down, power goes down. And then what contributes to effect size? Increasing the mean distance will increase your effect size, will increase your power. Decreasing the standard deviation within groups will increase your effect size, will increase your power. So those are all the things that increase your power and increase your effect size. Now, how does this work with rejecting the null? The bigger your power, the bigger your effect size, the greater chance you have of correctly rejecting the null. So the bigger your power, the bigger your effect size, the greater the chance you have of correctly rejecting your null. And you might be wondering, and this would be a fair question, can my power get so large that I might now start committing a type 1 error and reject my null when I shouldn't? And yes, that is a remote possibility, especially in psychology. You have to have millions of data points before you start worrying about that. So that's why I feel comfortable saying increase power, increase effect size, all leads to correctly rejecting the null. Okay. All right. Hopefully that helps with that question. By the way, if I'm not sufficiently answering your question, please feel free to chat back in. And if you can give me a little more specificity or something that didn't come across clearly, I'll be happy to address it again. Okay. What else? Okay. Um, so the homework problems versus the problems I'm talking about here. Um, I Yeah, I'm not sure exactly how to address that. Um, so I can give you a couple of ideas for the homework. Please bear in mind, like I said, I always give you variances for the homework. And the tricky part might be finding, and it gives you the data so you can calculate your means, right? Um, I guess the tricky part could be finding the mu, finding the population mean, because it might not say mu is this, but I tried to give you at least a clue by using the word population or using the word typical or average, something like that to help show you where the mu is. But if there are specific questions you want to ask about the homework, I'm happy to address that. Um, yeah. If anything, I don't wanna throw you the wrong way either, but I feel like, you know, the ones I'm doing today are probably more similar to what you'll see on the exam than the homework, but I don't wanna, like, say that and then throw you off. So I want you to do well in the homework too, let's put it that way. So, if you want to bring up a specific question about a homework problem, I will try to address it. But I feel like that it's just if it's anything, it's the wording on the homework might be slightly different. It might be a little bit harder to pull out. Typically, I think I gave you the variance kind of straightforward like. Okay. If you're set, by the way, do feel free to drop off. That's just an indication to me that you're set and you're feeling good. If not, please feel free, and if you want to hang back, please feel free to hang back too. I'm happy to hang out here and see if any other questions come up. You might be reviewing your notes and trying to figure out if you have any other questions. I'm fine with that. So really up to you. And who's left? We have 3 people left. Okay. So, 2, I noticed 2 of the 3 of you came on a little bit later, and there was that question about the Z and T table. Um, I'm going to start readdressing that, I guess, in just a moment because I wanna answer that for you. Um, but I just am waiting to see if there's any other new chats that come up. So let me give you just another few moments to see if that happens, and if not, I'll readdress the T and Z table cutoffs. Okay, let me go ahead and readdress the Z and T table cutoffs. Okay, so let me start with the T table because that's what I have open, and why not? Because that's the easier one. So for the T table, for the cutoff, what we're looking for is, first of all, is it one-tailed or two-tailed? That's our first question. So once we figure that out, we know if we're on the left side or on the right side. If we're on the right side, then we'll be looking for both being higher than the positive or lower than the negative. If it is one-tailed, we will only look for one side, and we have to know which side we're looking for. Okay, so in the two-tailed side, we have to know whether our alpha is 0.05 or 0.01. It'll never be 0.10. It'll never be 0.10. It's either going to be 0.05 or 0.01. Okay. All right. So next we have to know our DF. And our DF is different depending on which t-test we're using. If it's a t-test for a single sample or a t-test for dependent samples, it's n-1, sample size -1. If it's a t-test for independent samples, it's sample size 1 plus sample size 2 minus 2. So let's pretend for a second that this is a two-tailed test, 0.05 alpha. And I'll use the same example as before. We have sample 1 has an n of 12, sample 2 has an n of 10. We add the two together, we get 22, minus 2 gives us 20. So if we go down to the two-tailed column, 0.05 down to 20. Yes, down to 20. It's a little hard to see where this lines up. It's, I believe, yeah, wait, 2.086. So that would be either bigger than positive 2.086 or less than negative 2.086. Okay, all right. Sorry, did I share this with you? Hang on a second. I may not have shared this with you. I'm checking right now. No, I did. Okay, good. If it had been one-tailed and the same exact setup, 0.05 DF of 20, then the number to beat would have been 1.725. And it would have been either higher than positive 1.725 or lower than negative 1.725. And that just depends on the direction that your setup was given to you. Then we talked about the Z table. And I'm just going to tell you that for the Z table, the place you're looking is, here we go, Z table. And let me make sure you have that shared with you. You do. Okay. For the Z table, there's basically 4 numbers you can memorize. And it might be a way to go because I know the Z table is a little bit harder, but I'll show you the first one and then I'll tell you the other, well, I'll tell you the first, I'll show you the first 2 and then I'll show you the other 2, tell you the other 2. If it's alpha of 0.05 and it's one-tailed, then you're going to have 5% in your tail. So I scroll down all the way until I find something close to 5% in my tail, which is right here, the 5.05. I go to the left. My cutoff is 1.64. Either 1.64 or, depending on how I'm looking at it, negative 1.64. If it was a two-tailed test, I would have 2.5% on each side. So then I got to find 2.5%, which is right here. 2.5% is right here. And to the left is 1.96. This time it can be higher than 1.96 or less than negative 1.96. The only other situation could be an alpha of 0.01. And I will tell you that if it's one-tailed and 0.01, the cutoff is 2.33. If it's two-tailed and 0.01, the cutoff is 2.58. So as I was sharing before, since the requirement is that you are doing a note sheet this time, that you could just put those numbers on your note sheet. Okay, or maybe what I just shared with you made you feel more comfortable. Looks like we have one more question, which is, when will this be posted on YouTube? If I get a chance before my 10 o'clock class, I'll post it then. Actually, I won't, because this has to all like process and go through. So it probably won't go up then. So I'll put it up at 11. Okay. So takes 10 to 15 minutes to go up once I put it up. So give it until between 11 and 11:15. Okay. It'll be up there. I'll make sure this goes up first. Okay. Yes, you're very welcome. Okay, that's just about time. Any last second questions before I end the session?
Have a nice day.
Okay, you too. You take care, Preston.
All right, thank you.
Okay. Lauren, anything else for you? Oh, I guess not. Okay. Bye, everyone, and have a great day.